today we will actually talk about the subtractor. So we already work with subtractor in lab, but today we actually learn how you could design that. So we want actually, what we want to do today, we want to actually make 4-bit subtractor using 4-bit adder. So what it means? It means we don't want to actually have a new hardware that's able to do the subtraction. We just want to use the adder which we already made the hardware, and we know we have a circuit that's able to do these 4-bit adder. We want to just make some small changes on that 4-bit adder and turn that to the 4-bit subtractor. So let's see how we could do that, okay? So for doing that, so if you remember from our not previous class, probably in the beginning of this semester, we actually talk about the first complement, right? Remember that we say, okay, whenever you want to have the subtraction, you could actually use the first complement concept. So how it works, remember that we say, okay, whenever you want to actually say x minus y, you want to actually find this subtraction, okay? So we actually learn you could actually get this subtraction with just use the add. How? You say, okay, I just add with these y, these x plus y double prime. What is the y double prime? Is the first complement of these y, okay? So then I check the result, okay? There is actually two possibilities, two scenarios. Remember that? So anyone remember to tell me whenever you actually add with the first complement of the y, definitely there is a two case, right? The one is carry is equal to 0. The other possibility is your carry is actually 0. Could anyone tell me, remember from chapter 1, whenever carry is 1, what we need to do? You could actually type on chat box. So remember from chapter 1. So you add actually with first complement, then check the carry. Whenever carry is 1, what we do? Remember, we say you actually eliminate the carry and add 1 to that, okay? So whenever the carry was 1, we say delete the carry and add what you got as a x plus y double prime and add 1 unit. Okay, so whenever carry was actually 0, you say, okay, take 1 complement with negative sign, right? With negative sign. Okay. So remember this, we actually learned this in the chapter 1. So I repeat that again. You want to actually do x minus y, you say x plus first complement of the y, so check the carry. If carry is 1, you ignore that carry and add 1 unit to whatever you got as x plus y double prime. If carry is 0, you need to, whatever you got, take actually the first complement or 1 complement and you just add the negative sign with that. So whatever you will got will be actually x minus y. So that means somehow you are able to get the subtraction. We just use the add sign, right? We are going to use exactly the same concept. So that means I have, yeah, before actually I explain the circuit, let I mention to one actually the other things here which we will use that concept whenever we want to design the subtraction. So this is the first one that you need to remember from chapter 1. So the second thing that I want to here to mention, and I use that concept whenever I want to design the subtractor, is this. Actually add here, I say you could use XOR gate as a switch. Again, we learned this in chapter 1. Let's see what I mean. So if you have one XOR gate, so suppose this is your XOR, okay? So if you have two inputs, I call one is X, the next one I call that C, or the control pin. So you have the output, which is, remember, that XOR, right? You say X C prime plus, this is the definition of the XOR, right? So X C prime plus X prime C. Okay, so this is, we already know. So now I actually do this. I tell you, I give you two values for C, which is, I call that the control pins for the XOR. So if I give C1, what should be the output if you call this equal to F? F is our output. And C equal to 0, okay? You tell me, type in the chat box, what should be the F whenever C is 1? So whenever C is 1, so you just comes here, you say, okay, whenever C is 1, C prime is 0, 0 time anything is 0, plus C is 1, 1 actually time X prime, so the F is X prime, right? So how about C equals 0? Whenever C equals 0, just type it in the chat box. What should be the F whenever C is 0 based off definition of the XOR? Put here C is 0 and tell me what is the F. Yeah, whenever you have C is 0 back here, so this is C times 0, this is 0, 0 prime is 1, 1 time X, your X, okay. This is the second thing that we use in design subtractor. See, whenever you have the XOR and consider one of the inputs as a control pins or control input, with giving these 0, 1, you are able to get the same as the first input, which is the X or X prime, right? That means whenever you need to get the one of the input in the output as itself, which is the X, or as its prime, which is happen here, X or X prime, definitely you could use actually one XOR gate, which you actually control. You want to have X in the output, you need to give C as 0, right? So if you want to, the X prime will be in the output, you should give C equal to 1, okay? So somehow it's obvious based on the definition of the XOR, right? So we keep these as a second point whenever we want to design the actually subtractor, okay? So now let's go back to our main topic. Right now I want to design a 4-bit subtractor with using 4-bit adder. I want to use these two concepts that already learned in chapter 1. So the only tools that I have is just one 4-bit adder, okay? So I have here the 4-bit adder. So definitely 4-bit adder actually has two inputs. One is for X, 1, 2, 3. and another one for y. So if I want to use this, so I say, okay, I want to calculate x minus y, but if I use this concept that I learned in chapter 1, I just need to say x plus y double prime, which is the first complement of the y. So you tell me, what should be these first input should be connected to which numbers, x or y, if I want to use this concept here, what I should connect here. So definitely if you check this, so you need to have the same thing, the first number, no change on that. So that means here, definitely you should connect x0, x1, x2, x3. I do that with the other color. So how about the second 4-bit that I have? What I need here as a second input, you tell me. Based off this, you need to actually add with the first complement of the y. So the question is how you could, the y is the binary number, how you could get the first complement of any numbers in the any binary numbers. Any idea? If I give you a binary number, how you could get the first complement of that? So this is a question that we had. Yeah, definitely is a not. Yep, that's definitely right. So plus this, that means the second input should be just not. Why? Because whenever you want to find the first complement, you change 0 to 1, 1 to 0. What it means? It means you just actually not the second number. So I use 4 nots here. So if I change the colors, so definitely I could label them. So it should be x0, x1, x2, x3. Here you have the same thing, y0, y1, y2, and y3. So definitely I have one C in. So for now, I have no idea what I need to do with this. I have the 4 outputs. Let's think about the outputs. Okay. So I want definitely use this concept. I add the x plus the first complement of that, which is this. So then what I need to check the carry. Where is the carry here? Is this C4 that we already know, right? So this C4 is this carry that we have. So if this carry, I need to check this. If carry is 0, I need to take the one complement of the output. If the carry is 1, I need to delete the carry and add 1 unit. So that means if C is 1, I don't need to take the actually first complement of my output. So whatever you got, it should be your output. If that's 0, I need to take a 1 complement. So that means if you are in overall, what's happening in the output? Case number 1 is carry is 1. That means there should be no first complement. Whatever you have here is your output. Case number 2 is C0. So that means you need to take the actually first complement. So that means these S that I have here, S0 to S3, there is 2 situations here. First, the S should be the S, the output, or the S should be the first complement, which is the prime, right? So that means you need to take you need to take the first complement or no change on the output. Okay, so that means somehow I need to have the whole of these 4 as an output or take the first complement, which means take actually the not, right? So that means the S should be the same thing here that I have, or I need to take the actually not of them. So do you know any switch that's able to do that? That means pass these as it is. So that means the S0 to S3 or take a prime. So this is what we have here. If you need to pass that as a itself, which is the X or S or the prime, definitely the best switch is XOR. So that's the reason I'm going to actually put 4 XOR gate here in the output. This is 1, this is 2, this is 3, and this is 4. So what I'm going to do, I'm going to connect these. S definitely should be one output of them. This goes, there's a S, then I need to have the control pins, right? The control pins. So I actually changed the color, probably it should be more obvious what I'm doing here. So I need this control actually input, which is tells when it should be the no change on the output and when it should be prime. So I actually connect all of them to just one pins. I call that C, the control. So that control pin is same for all of them, right? That is same for all of them. That means I have these C, the control. I actually connect for the all of XOR. So that means each of these XOR, one is the S, and another one is actually the control, which is whenever the case this C is 1, you tell me. Whenever C is 1, the carry is 1, you tell me these control should be 0 or 1. Whenever the carry is 1, that means you add these X with these first complement, then you check these carry 4. So this is case 1, C1. So you tell me what should, if this is the case, what should be the C, 0 or 1? That's the main question. 0 or 1? 0. So see, whenever this is 1, you say delete the carry and add 1 unit. Could you see any take a 1 complement, which is the take the prime? No, there is nothing like that. So that means whenever C is 1, so that means is actually no taking the prime. So C should be 0, definitely right. The C should be 0 because you just pass whatever you have here, no change. Whenever you are in second case, which is this, so that means that you actually need to take the complement. What should be the control switch here? Should be 1 that give you the prime. So C should be 1. So that means this is one design problem. I'm actually coming to this other side and make some design. Okay, so let's do change the color. So I want to know where I need to connect these actually control that I have here. I call that C, okay? So I consider this C, which you have here. I don't know, maybe we need to give the other name. C, I don't want to mix up with this. What we call this C1. Let's give C1. I don't want to have the same name with this C that I use here. So you want to know what you need to do with this C1. Okay, you want to design a combinational circuit. Okay, you call that function C1. Okay, you want to design that. So the first thing for design any actually circuit is to know, okay, you have function C1, you should know what is this function is related to which variables. You tell me this function is related to which variables we have here. If I call this C4, so you tell me who tell us this C1 should be 0 or 1. Definitely the carry that you have from X plus Y actually double prime, which is this C4, right? So I say, okay, C1 is a function. It's just related to this C4, okay? This C4, which is the carry of this add X plus double prime, tell me what it should be 0, which is give the same S, or it should be 1. Say, okay, I have C1 is the function, it's related to the variable C4. So you have C4 variable, this is a design problem, we already did this. So C4, so you have just one variable, the whole possible case, C4 could be 0, 1, right? So whenever C4 is 0, you tell me what we should have for C1. You tell that, I actually know you understand what I'm talking here. So whenever the C4 is Yeah, definitely. So see, whenever C4 is 0, this is this case, right? You need to take the first complement or one complement. So how I could take the first complement? So C should be 1, right? So that means C should be 1. That's exactly right. So whenever C4 is 1, what should be the C font? C1. Yeah, definitely should be 0. Why? Because this is this case. The carry is 1, which is C4 is 1. And you don't need to take it to complement. Whatever you have as a S, it should be just passed through the output, which is definitely whenever the control is 0, it's actually pass whatever you have. So see, that's it. So right now you want to make this function. You tell me if I make this function C font based off C4, what we have. Is it right? I say C1 equal to C4 prime. Is it right? The answer is right. So the C1, whenever C4 is 0, you take not, you have 1. Whenever this is 1, you take a not, it's 0. Okay, that's simple. So that means what I need to do here, I use just one not in C4 and connect that to C1, right? So that I complete this. So whatever you have here as an output definitely should be S0, S1, S2, S3, okay? So this is actually somehow one part of the design, which is take care of these two, but still we have some other actual issue here. Whenever C take care of this C1, whenever you see C is 1, we say delete the carry. That means you ignore the carry and add 1 unit. Whenever C4 is 1, how I could add 1 unit? So definitely I need to actually connect this C4. So C actually connect this C4 to this Cin, which is means whatever you have here. Whenever C4 is 1, so that means you give Cin 1, which is the same thing that you add 1 with these two, right? That's the meaning of the Cin. That means we connecting these two here. I take care of this part, okay? And I already take care of this take a one complement or not, we take care of that. So the only thing left here is the negative sign. Definitely I should have one output which actually tell me when number is negative, because if whenever you say x minus y, if x is smaller than y, definitely you should get actually the negative. So that you say, okay, I designed the sign. So see, this is again another design problem. That's how I could design that. I'm looking for the function. I call that sign, right? So the first thing you need to figure out, okay, you have the Boolean function, you call that sign. The first question is, sign is the function. It's related to which variables that we have here. You tell me. If the sign is function, who tells us you need to actually have the negative sign or the positive sign? It's sign related to which of these labels that you see here. Type it on chat box. So the sign is related. Who tells here the number is negative or positive? Which parameters that we have? C1, C4, which one? So the answer is simple, right? Yeah, definitely is C4. So you back here. So whenever C is 1, it's positive. Whenever C is 0, you take it to complement that to negative. So you say, okay, I have a function. It's just related to one variable, okay? It's just related to C4, okay? So then that's actually the design problem. This is your truth table. You have one input. It could be 0 and 1. So then complete the truth table. So the C4 is 0. You tell me the number is positive or negative. We could actually write here. So you could say, see, this is what I want to do. So the sign, I actually put output. I call that sign. Whenever that output is 1, it means negative. Okay. So negative when a 0 means P or positive. Okay, positive. Okay, 1 negative, 0 positive. Okay, you could actually do opposite of that. That's up to you as a designer, okay? So you could say 0 is positive, 1 is negative. That's up to you. But for here, we actually, this is what we want to do. Sign 1 means negative, 0 means positive. So back here, the C4 is 0. So the sign, we should have positive number or negative number? Negative number. Why? Because of these concepts. C is 0, you need a negative. What is the negative? Is 1. So you have 1 here. So whenever C4 is 1, you have the positive. What's the positive? Is 0, okay? So again, if you check this, the sign equal to C4 not, right? So that means it's equal to maybe right here. So again, based off that truth table, the sign equal to C4 prime, okay? So that means C4, this is the prime, and this is my sign, okay? So that's it. You actually design one 4-bit subtractor using actually 4-bit adder